Hi everyone, Miss Andronica is here, and today we are looking at Pythagoras' theorem. Pythagoras' theorem is one of the most well-known theorems in mathematics. It concerns right-angled triangles. There are a few formulae that we have in mathematics that every time you see a right-angled triangle, you need to think of them, and this is one of them. So right-angled triangles, Pythagoras' theorem. It is a theorem that joins or connects or has a rule connecting the sides of your right-angled triangle. Okay, so it concerns the sides only. As long as that right angle is there, then this will work for its sides. Pythagoras' theorem tells us this formula: a squared plus b squared equals c squared. Now, the a, the b, the c refers to the sides of your right-angled triangle. Now, a and b really can be interchangeable. There's no real rule around which ones they are. The only absolute critical rule is C. It must be the hypotenuse. It is the longest side and it's the opposite from of the right angle. So the right angle is always opposite the hypotenuse, never touching the hypotenuse. It's always that longest side in your right-angled triangle. A and B, because they are squared and added together anyway, they are technically interchangeable. So that's fine. A squared, whatever the length of B squared is, equals whatever the length of C is and squared. Okay, let's look at an example of this. So for this example, on the triangle below, side AB, here's point A, here's point B, is 13 centimeters. So AB is 13 centimeters. The first thing I'm going to do is label my diagram. Side AC is 24 centimeters, AC 24. If I didn't have a diagram, I would draw one and then label it. Work out the length of BC. Now, it happens that even though we know this is a right angle triangle, we have two of the three sides, we know a squared plus b squared equals c squared. Please keep in mind we've got side A, side B, and this is side C, and that's all little letters. So once we have the formula down, we know the little letters refer to the actual side, so side A, side B, side C. These capital letters refer to the points, and you can see that also they can be described like side AB, for example, in the question. Now we have the information on the diagram, we just need to replace the formula. So you can replace either A or B with that 13 squared. It's fine, it doesn't make the difference in this instance as long as C is 24 squared. So it has to be that. Once you do that, obviously then you need to follow BIDMAS and complete these. So once you get this, you just solve as usual. So here I'm going to subtract that from both sides, cancels it out. B squared therefore equals 2, 3, 8. And then to get rid of that squared, we want to square root both sides. So therefore B equals 15.43 centimeters to the nearest two decimal places. 1 or 2 is fine. Okay, the last thing you need to make sure that you do with Pythagoras is to check how reasonable is this answer. So if I say that this is around 15.5 centimeters, is that reasonable when it comes to looking at these triangles? Is that reasonable? Yes, we've got 13, a little bit more, 15, and then the longest one must be the hypotenuse. Okay, there you go. Give it a go.